Okay, so before the break, we did 7.1 and we spent 2 days on 7.2. We're going to finish this off today. I put on the board that you guys are going to write a quiz on 7.1 and 7.2 on Wednesday. So that'll give you an extra day to get ready for it. And then after chapter 7 is all done, you'll have your exam on chapters 6 and 7. Okay? So we'll be getting ready for that. We still have probably most of this week to go before we'll be done chapter 7. So some things that we learned about in 7.2, excuse me, we did the general form of an equation, which is where you have everything on one side equal to 0 on the other, no fractions or decimals, and the x term was positive. That was different than slope-intercept form, which was y equals mx plus b. It told us the slope and the y-intercept. The general form, really, all it tells us is what the y-intercept is. It is the constant term of an equation. Okay? So, just as a review, the table shows the input and output of a linear function. The input would be the x, the output would be the y's. Which point below is not on that line? So we're told that it's a line, which means that the rate of change is constant. All right? So if you look and see what's happening here, the x values are increasing by 1 as you go down the list. The y values are also increasing by 1 as you go down the list. So you can continue that pattern. The next x value after 2 would be 3, and the next y value after 5 would be 6, which is what point A is. So that is a point on the line. We want to know which point is not on the line. The next point we have to look at is the point negative 3, 0, and we can write what that value is on this table by going above the table. Above the table. As you go down the table, x increases by 1 and y increases by 1. So as you go up the table, they'll both decrease by 1. An x value of negative 3 would give us a y value of 0, which is point B. So that is a point on the graph. So that's not our answer. The next one we have to look at is a point 5, 8. So if we continue the pattern down the list, as x increases by 1, y increases by 1. Sorry, I put the wrong x number there. It should have been 4. As x increases by 1, y increases by 1. The point 5, 8 is on the table, is part of that relation. So our only answer could be the point negative 5, negative 2. So to check that, we will continue going up the table. So if you decrease 1 from negative 3, you'll get negative 4, and that'll be negative 1. And then negative 5 will be negative 2, not positive 2. So that's why the answer is D. The point 5, 2 is not on the graph. It should be the point negative 5, 2. The other reason that we knew that was true is because if we look at that point right there with a y value of 2, the x value should be negative 1, not negative 5. So you could have done it that way as well without extending the pattern going up. Okay? The next one, a line passes through those 3 points. What is the x-intercept of the line? Now, you can actually do this one without any work. Princess, how do you find the x-intercept of any graph? Do you remember? Jan? That's right, you let y equal 0. And that's this point right there. That is the point where y equals 0, x equals 1. So that is the x-intercept of that graph. Remember, the x-intercept is where the graph crosses the x-axis. To get there, you don't go up or down, you just go left or right. Because you don't go up or down, the y value is 0. Right? So in this case, didn't have to do any work at all. The answer was in the question. The next one says, what is the y-coordinate of the y-intercept of the line that passes through those 2 points? So in this case here, you're looking for the y-intercept. And the y-intercept is where x equals 0. That's not one of these 2 points. Okay? However, there is a pattern here. If you look at the points, in each case, the y value is equal to the x value. The y value is equal to the x value. So the y-intercept, which is where x is 0, will also have a y value of 0, because these 2 points follow the pattern that the x value and the y value are the same number. The y-intercept is where x equals 0. That means in this case, y must be 0 as well. And the question is asking, what is the y-coordinate of the y-intercept? Okay. And so that is 0. The next one, a line that has a slope of 1/2 and passes through the point 3, 4. Which point below lies on that line? Okay, so because you're given the slope and a point on the graph, you can find the equation. And we did this before back in some previous work. And we did this by using the slope-intercept form. So that was one of the forms. Actually, I don't remember if I think we did look at this. Y minus y1, yeah, we did, equals m bracket x minus x1. We did the point slope form before. That's what this is. So remember that most equations have an x and a y in them. That's where the x and the y come from. Most equations have an x and a y in them. The point that we're given will be our values of x1 and y1, and m is the slope, which in this case we're told is 1/2. So if we plug those into the equation, y minus y1, which is 4, equals m, which is 1/2, bracket x minus x1, and x1 is 3. So this is the equation in the slope-intercept form. So y minus 4 will equal 1/2 x minus 3/2. If you multiply out the bracket on the right, you multiply the x by 1/2 and the negative 3 by 1/2. And then we would add 4 to both sides. And instead of adding 4, I will add 8/2, because I need a common denominator to combine it with the minus 3/2. I need to write 4 with a denominator of 2. So that's why it's 8/2. 8 divided by 2 is 4. So if I simplify this, negative 3 plus 8 is positive 5/2. And so this would be the equation of that line. So we want to see which of these points lies on that line. So which point will satisfy this equation? So if you check the point 2, 4, when x is 2, y will equal 4. So if we plug those values into the equation, and 5/2 is 2.5, half of 2 is 1, and 1 plus 2.5 is 3.5, not 4. So let me just move these over a little bit. Four does not equal 3.5, which is what you get on the right when you let x equal 2. So this is not our answer, because that point does not lie on the graph. It does not satisfy the equation that we figured out. So let's go to the next point, the point 2, 6. Y is 6, and x in this case is again 2. Well, in this case, we already figured out what happens when x equals 2. On the right side, half of 2 is 1 plus 2.5, again, is 3.5. 6 does not equal 3.5, so that point doesn't work. Checking point C. The y value is 6. Now the x value is 4. Half of 4 is 2, and 2 plus 2.5 is 4.5. But it doesn't matter because we still don't get the same number on both sides of the equation. So that means that that point does not lie on the graph of a half x plus 5 halves. So the last one we have to check is the point 5 comma 5. Y is 5 when x is 5. Half of 5 is 2.5 plus 2.5 does equal 5. Here you do get the same number on both sides when x is 5 and y is 5, which means it does satisfy this equation that we calculated. Therefore, that point does lie on that line. Okay, so that's one way to do it. Another way you could do it is by using the slope and the point. So this would be an alternate solution to this problem. So if we start with the point 3 comma 4, and the slope is 1/2. Remember, slope is rise over run. You're going to rise 1 and you're going to run positive 2. If you rise 1, that means the y value of 4 is going to go up by 1. It'll become positive 5. And if you run positive 2, that means going 2 to the right, you're going to add 2 onto the 3, which also gives you the 5 comma 5. So that would actually be an easier way to do this problem. Start with the point you're given at 3 comma 4 and apply the slope of 1/2. And remembering that slope is rise over run. Rise 1 means the y value increases by 1 from 4 to 5. Run 2 means the x value increases by 2, so it goes from 3 to 5. And so by doing one application of the slope to the given point, we get the right 5 comma 5 answer. So 2 ways that could be done. So this question asks for the y-intercept of that graph. Do you know what it is, Keaton? Well, this is in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. This is in slope-intercept form. It is in y equals mx plus b, where m tells us the slope and b tells us the y-intercept. So what's the y-intercept, Keaton? M, the number in front of x, tells you the slope. The slope of this line is positive 3. And b tells you the y-intercept. The y-intercept will be negative 2. That's what slope-intercept form tells us. So there's no work that had to be shown for this. The equation tells you the slope and the y-intercept. Yes. Can't hear you. Okay, make sure you sign out. Okay, which equation is graphed below? So looking at this graph, you can see that the y-intercept is positive 2. And you can also count the slope. So again, the y-intercept is positive 2, which remember, if we use slope-intercept form, that's our b value, positive 2. Now, m tells you the slope. So we need to find a point that is on this line other than the y-intercept, which is the point 0, comma 2. And we could use the point 1, comma 6. That is a point that lies on this line. And you can count the rise and the run and then calculate the slope. So if we rise up and then run over, the rise is 1, 2, 3, 4, and the run is positive 1. This line rises as you go left to right. That's one reason why the slope is positive. Also, if you go from the y-intercept to the point 1, 6, you're going to rise positive and run positive. That's another reason why the slope is positive. So m, the slope, is 4 over 1, which is 4. And our equation will be y equals 4x plus 2. I wrote it in slope-intercept form. Now, if we look at all 4 equations that we have to choose from, 2 of them are exactly in general form. The other 2 are close to general form. The difference being is that general form, we always make the x term positive. Answers B and D have the negative x term, but that's okay. I'm going to put this equation in general form. By moving the y over to the right, it'll be 4x minus y plus 2 equals 0. So that is the equation of this line in general form. This also tells us that neither A nor B can be the right answer. Okay? And the reason we know that is the equation that we wrote has a 4x as the first term, but the second term is minus 1y. Our first choice here has a positive 4x as the first term, but the second term is positive 2y, not minus 1y. If you multiplied everything by negative 1, you'd get a negative 4x and a positive y. So you got the negative 4x all right, but the second term is positive 2y, not positive 1y. Okay, so that's how we know that neither A nor B can be the correct one. Let's look at answer C. It has a first term of 8x, which we would get by multiplying everything here by 2. You'd get a positive 8x, a minus 2y, and a plus 4. And if you multiply the left side by 2, 0 times 2 is still 0, so that doesn't change that. But you'll get a positive 8x, a minus 2y, and a positive 4. So we're close, but the wrong sign for the 2y and the 4. But if you multiply this by negative 2, you'll get a negative 8x, which is right. You'll get a positive 2y, which is right. And you'll get a negative 4, which is right. So that's why D is the correct answer. You can multiply an entire equation by a constant, and it won't change the value of that equation. And we did that when we converted from different forms into general form. If we had an equation that had a denominator, we multiplied all the terms by the common denominator. We multiplied every term by the same number, and that's all we're doing here. So you can absolutely do that as long as you multiply all the numbers by the same value. Okay, what is the slope of that line whose equation is y minus 3 equals negative 2 bracket x plus 2? So remember, if we can put the equation in y equals mx plus b, it tells us not only the slope, but also the y-intercept. M is the slope, b is the y-intercept. So to get that, we need to get positive y by itself. So my first step here, probably what I would do is I would multiply out the brackets on the right. It'll be negative 2x minus 4. And then we will add 3 to both sides, and we'll get negative 2x minus 1. So Cherry, what's the slope of that line? That's right, because it's in slope-intercept form. M is the number in front of the x. That tells you the slope. Negative 2 is the slope. 3 of the 4 statements below are true of a line. So which statement cannot be true? So if we look at these 4 statements, statement A says that the slope of the line is negative 2. B says the x-coordinate of the x-intercept is 3. Remember that the x-intercept is where y equals 0, so that's the point 3, 0. The y-intercept is 0, 4, and then those 2 points lie on the line. Now, if you look at this point right here, it shares the same x component as the stated coordinate of the x-intercept. They both can't be right. Right? Answer B says that when x is 3, y is 0. Answer D says when x is 3, y is negative 2. So one thing we know for sure is that B and D cannot both be correct. Because they state the same x value but different y value. So they can't be correct. All right. Now, statement A says the slope is negative 2. D, you've got 2 points on the line. So we can use the slope formula to find the slope of the line in answer D. Remember the slope formula. y2 minus y1 over x2 minus x1. And this formula will be given to you on any quizzes or test if you need it. And remember, when you're using slope formula, one of the points will be 0.1. That'll give us our x1 and y1 values. The other point will be 0.2, which gives us our x2 and y2 values. So y2 minus y1 will be negative 2 take away 6 over x2 minus x1 will be 3 minus negative 1. Negative 2 take away 6 is negative 8. 3 minus negative 1, the minus minus becomes a plus positive. It'll be 3 plus 1, which is 4. And that gives us a slope of negative 2, which is what A indicates. A says the slope of the line is negative 2. So if only one of these statements is incorrect, and we've now seen that A and D is correct, that would tell us that B would be the one that is incorrect. Because B and D cannot both be correct. We've established that D is, therefore B is not. Now, if you wanted to, the slope is negative 2, all right? So you could use one of those other points that were given in part D to show that the y-intercept is 0, 4. Okay, and so to do that, if we start with the point negative 1, 6, and our slope is negative 2. So that's our rise over our run. If we rise negative 2, we are going to run 1. Now, if we want to get to a slope of negative 1, if we want to get to a y value of 0, because that's where the x-intercept comes from by letting, the y-intercept comes from by letting x equal 0. If I apply this slope of negative 2 over 1, which means you're going to rise negative 2 when you run 1, a rise of negative 2 means the y value will be decreased by 2, and a run of positive 1 means the x value will be increased by 1. And that gives us the point 0, 4. So that proves that point C, or statement C, is also correct. We took the point negative 1, 6, and we applied our slope of negative 2 over 1. And when you do that, you'll get the point 0, 4. So again, that just verifies that statement C is also correct. So on to the next one. A line has an x-intercept, of negative 2, 0, and a y-intercept of positive 1, 0, comma 1. Which of the following is true? So the first statement says the line passes through the y-axis below the x-axis. So what we can do here is we can draw a sketch of this line. We are told what the x and y intercepts are. The x-intercept's at negative 2, comma 0. The y-intercept is at 0, comma 1. So this line would look something like that. When we put our x-intercept of negative 2, comma 0 and our y-intercept of 0, comma 1, that's what the line would look like. The first statement says that the line passes through the y-axis below the x-axis. That's not true. It passes through the y-axis above the x-axis. So that is not a true statement. The line slants downward from left to right is what answer B says. Well, that's not true. It slants upwards from left to right, which is what answer D says. To eliminate answer C, the line passes through the x-axis to the right of the y-axis. That's not true. It passes through the x-axis to the left of the y-axis. So this just confirms then that D is the correct statement. Okay, so let's look at this one. Brad wishes to burn 1,200 calories by either jogging or playing tennis. He can burn 400 calories an hour playing tennis and 625 calories per hour jogging. We're asked to write an equation in general form to describe the number of hours that Brad would need to play tennis T and jog J so that he could burn 1,200 calories. So we are told what our variables are. T is the number of hours playing tennis. We're already told this. And J is the number of hours jogging. We are told that he burns 400 calories an hour playing tennis. So 400 calories per hour times T hours of playing tennis, that'll give us the number of calories burned playing tennis. And he can burn 625 calories per hour jogging. J is the number of hours jogging, so this term will tell us how many calories he burns jogging. And he wants to burn 1,200 calories. So that equation must equal 1,200. Now it does say to write it in general form, which means we need to move the 1,200 over to the right side by subtracting it from both sides. Because remember, general form doesn't have any fractions or decimals, and it has to equal 0. And we also say the x term must be positive. We don't have x and y as our variables in this, so we'll just make sure that either t or j is positive, and in this case they both are, so we're fine. Now, part B says, what are the two intercepts and what do they represent? So if we want to find the t-intercept, how do we do that, Keen? How do we find the t-intercept for this equation? How do we find the t-intercept? See, not all equations are in terms of x and y. You can have different variables like this one. And so you would just decide which variable or which axis will be the t-axis, the other axis then would be the j-axis. Okay? But how do you find the t-intercept? Yeah. Don't remember? Can you help him, Peyton? Take your earbuds out. Can you help him, Stanley? Take your earbuds out. Jan, save the day again. That's right. The x-intercept is where y is 0. The y-intercept is where x is 0. No matter what the variables are, if you want to find one intercept, that's where the other variable equals 0. So the t-intercept in this case will be where j equals 0. I'm going to use the first equation that we wrote, the one that has the 1200 over on the right side. So we've got 400t plus 625 times 0. We're letting j equal 0. And that equals 1200. Now, when you let j equal 0, this term disappears. 625 times 0 is 0. 400t plus 0 is just 400t. And then to get t by itself, we would divide both sides by 400. And that would give us a t value of 3. And so what that represents, we got that answer when j is 0. J is a number of hours jogging, which means that Brad is not going to jog. He would have to play tennis for 3 hours to burn 1200 calories. If he's not going to jog, he'd have to play tennis for 3 hours. So that is the t-intercept. But we also want to find the j-intercept. Keen, how do we find the j-intercept? By what? Because you're going to let t equal 0. Which, the next step would be what you said. The j-intercept will be where t equals 0. And so 400 times 0 is 0. So you're just left with 625j equals 1200. And now if you divide both sides by 625 to get j by itself, so on the right side, it'll be 1200 divided by 625, which is 1.92. And what does that number represent, Stanley? Huh? Say again. You don't have to yell, I'm standing right here. Can't hear you. But what does it mean in relation to this problem? What does that tell us? Sal, can you help us? 1200 calories. If he doesn't want to play tennis and he only wants to jog, he'd have to jog for 1.92 hours to burn 1200 calories. So we can write this out. If Brad only plays tennis he needs to play for 3 hours. And if Brad only jogs he needs to jog for 1.92 hours. So that's what that tells us. Part C says, suppose that Brad jogs for 48 minutes. how long does he need to play tennis in order to burn his 1200 calories? So if we start with our original equation, 400t plus 625j equals 1200, we are told that he jogs for 48 minutes. But remember that j is the number of hours playing tennis, or the number of hours jogging. So we'd have to write 48 minutes in hours by dividing it by 60, because there are 60 minutes in an hour. Right? Because j is the number of hours jogging, not the number of minutes. So we have to write it as the number of hours by dividing it by 60. So go to our calculator. So 48 divided by 60 is that decimal. 0.8 of an hour jogging times 625 calories per hour means that he will burn 500 calories jogging. So 400t plus 500 will equal 1200. We now need to solve for t. So we can subtract the 500 from both sides, and that'll give us 400t on the left equaling 700 on the right. And then we would divide both sides by 400 to get t by itself. And that'll give us 1.75, I think. 700 divided by 400. Yeah, 1.75. Which means 1.7 hours of tennis. He would need to play tennis for 1.75 hours. If he's already jogged 48 minutes, then again, he wants to burn 1,200 calories. Okay? On the next page, Spencer has 66 gigabytes of disk space left on his laptop that he's going to fill with TV shows and movies. Suppose a 1-hour show uses 1.1 gigabyte of disk space, and a movie uses 4.4 gigabytes. Write a linear equation that represents the number of TV shows T and the number of movies M that Spencer can store on his laptop. So we are told that T is the number of movies, TV shows I should say, and M is the number of movies. Each TV show uses 1.1 gigabyte. So 1.1 T would tell us how many gigabytes he has used for television shows. T is the number of TV shows times 1.1 gigabyte per show. Plus, M is the number of movies, and each movie is 4.4 gigabytes. So it'll be 4.4 M will equal how much is on the disk. And we can choose any variable we want for that. But actually, let me fix this, because we are told that he has 66 gigabytes of disk space left. So that must equal 66 at the most. It's possible it could be less than 66, but we're going to assume that he's going to fill it up completely. So there's our answer for part A. That's our equation. Part B wants to know what the t-intercept is. Keaton, how do we find the t-intercept? Say again? What other? Part B, we want to determine the t-intercept. How do we find the t-intercept for this equation that I've put up here? not the m-intercept. The t-intercept is where just m equals 0. The m-intercept is where t equals 0, so you wouldn't say that to find the t-intercept, because the m-intercept would be where t is 0. In this case, we want to find the t-intercept by letting m equal 0. So as we've seen, the term that has m in it is going to become 0. Because when you multiply 4 times 4 times 0, you'll get 0. And 1.1t plus 0 is just 1.1t. So 1.1t equals 66. To get t by itself, we would divide both sides by 1.1. And 66 divided by 1.1, I think, is 60. Check that. 66 divided by 1.1. Yep. Which means that he could download 60 shows if he does not download any movies. And we'll write a concluding statement at the end after we do part C. Part C wants to know what is the m-intercept. Chloe, how do we find the m-intercept? That's right, let t equal 0. So it'll be 1.1 times 0 plus 4.4 m equals 66. And again, when you let t equal 0, that term disappears. 1.1 times 0 is 0. 0 plus 4.4 m will just be 4.4 m. And we will divide both sides by 4.4 to get m by itself. So you get 66 divided by 4.4, which is 15. So, Princess, what does that tell us? Can you help her, Emery? Olivia? What does that tell us? If he downloads 0 TV shows, he can download 15 movies. So we'll write a statement for both. Spencer can download 60 TV shows with 0 movies and 15 movies with 0 TV shows. That's what it tells us. Part D says that he has 16 TV shows. So how many movies does he have space for? So if we use our formula again, which is 1.1t plus 4.4 m equals 66. And remember, t is a number of movies, t is a number of TV shows, m is a number of movies. We are told that he has 16 television shows, so t is 16. How many movies does he have room for? So now we want to solve for m. So on the left, 1.1 times 16 is 17.6 plus 4.4 m equals 66. we would subtract the 17.6 from both sides. Which leaves us with 4.4 m on the left. And on the right, 48.4. And then to get m by itself, we would divide both sides by 4.4. And gives us an answer of 11. So if he already has 16 TV shows on his computer, he has room for 11 movies before it's filled up. Okay? All right, I'm going to stop there. These are the questions that you need to work on for practice. Again, you have a quiz coming up on Wednesday on 7.1 and 7.2. So 7.1, if we go back, Seven point one dealt with our slope-intercept form, our y equals mx plus b. And 7.2, we learned about general form and finding the intercepts. So that's what your quiz is going to be based on Wednesday. Okay, we're going to continue going ahead tomorrow on some new stuff. I'm giving you an extra day to get ready for your quiz. That'll be happening on Wednesday. Okay, I would recommend that you go back and you look at what we did in 7.1 and 7.2 prior to today, because those are the things that you need to know for your quiz, which is on Wednesday. Yes, Sal.
Monday.
Yeah, you can go to the bathroom. I need you to sign out though. Okay, so if you didn't copy down those questions, there they are. Yes, when she gets back.